Welcome back. This is the second lesson recording for IM2, December 7th, 2020. So now you're going to do some practice problems. You're taking notes in your notebook. You are solving four of these problems, multiplying polynomial using distributive property. No more area model, please. Okay, so I want you to get more practice on using the distribution property. Please pause the video and try to do them yourself. Remember, 3x plus 2 all squared means 3x plus 2 multiplied by 3x plus 2. Okay, let's go over them together. Using the distribution method, you are multiplying the first term of the first binomial, that's negative x, to the second binomial, that's x minus 1. And then you're getting the second term. To that, you're adding second term, which is plus 6 multiplied by second binomial. Okay, and then you use the distributive method or distribution where you're multiplying negative x to x and to negative 1. Okay, so negative x times x is negative x squared. Negative x times negative 1, negative times negative is positive x. Okay, negative x is like negative 1 is being multiplied to x. Okay, and then to that you're adding 6 multiplied by x, that's 6x. Then 6 multiplied by negative 1, that's negative 6. Okay, make sure that those negative signs do not get lost. Remember the negative signs, they belong to the number or the variable that follows. Now from here, you need to look for like terms to combine. Do I have any more x terms, x squared terms? No, I don't. So I am just going to write x squared here. Do I have any x terms? I have one here and another one here. So you need to combine those. That's 6 or 7x, I'm sorry, 7x, and then minus 6. That's my final answer. Okay, let's try this problem. 2x plus 5, 2x minus 5. Again, you're looking for the first term of the first binomial, that's 2x, multiplied by the second binomial, that's 2x minus 5. And to that, you are adding the second term of the first binomial, that's plus 5, and multiply that by the second binomial, which is 2x minus 5. So that's just that it would be 2x multiplied by 2x, that's 4x squared. Then 2x multiplied by negative 5, that's going to be negative 10x. And then 5 multiplied by 2x is plus 10x. And then 5 multiplied by negative 5 is negative 25. Okay? Something interesting is going to happen here. Okay, so now first look at for x squared term. Do I have any more x squared term? No, I do not, so that's going to be 4x squared. Do I have any x terms apart from negative 10? Yes, I have negative 10x and plus 10x. What is negative 10 plus 10? It's 0. So you have 0 lots of x, that which is same as 0. So I don't even have to write that. And finally, I have 25. So the final answer is 4x squared minus 25. This has a special name for it. It's called difference of square. Okay, and it's called that because you can do an area model where you are actually finding the difference of two areas. But this happens when you have 2x, the first number, the first terms of the binomials are the same. The second term are the same except for the operation. The one's positive, one's negative, but the number, the magnitude of the number is the same. So it's actually plus or minus, and when you see that, they actually cancel out here. Okay, so that is the reason you are multiplying binomial to another binomial and you end up with a binomial. Okay, so you can multiply binomial with binomial and end up with a binomial. Here you multiplied binomial by binomial and ended up with trinomial. Okay, let's look at the next problem. This is your first polynomial is a binomial. The second polynomial has three terms, so it's a trinomial. So you're multiplying binomial with trinomial. So again, using the distributive method, it's the same thing. You're getting the first term of the first binomial, so that's going to be 2 3x squared, and then multiplying that with whatever is the second polynomial. So that's going to be 3x minus 4x, so 3x squared minus 4x plus 7. And then you get the second term of the first binomial. So to that, you're adding the second term of the first binomial multiplied by the second binomial, 3x squared minus 4x plus 7. Okay, so the process is exactly the same using the distributive method. But remember, some of you are using the method FOIL because you've learned it from elsewhere. This is where the FOIL method breaks down because you don't have the first, last, and inside and outside because you are dealing with trinomial here. Whereas this distributive method would actually work for any situation. So in this case, 3x squared times 3x squared, that's going to be 9x squared, x to the power of 4. Remember, we are multiplying. Okay, there is a default of multiplication between the variable and the parenthesis. And then 3x squared multiplied by negative 4x. 3 times negative 4 is negative 12. X squared times x is x to the power of 3. 3 times 7 is 21. And x squared, to that we're multiplying x squared to it. And then negative 1 times 3 is negative 3 x squared. And negative 1 times negative 4x is positive 4x. And then plus negative 1 times negative 7 is negative 7. Oh, negative 1 times positive 7 is negative 7. Okay, now we are ready to see if there are any like terms we can combine. Do we have any more x to the power of 4 term? No, I don't. So I have 9x to the power of 4. I've taken care of that. What about x cubed? Do I have any more x cubed? Nope. So I have 12x cubed. What about x squared term? I have 2x squared terms. Okay, 21x squared minus x squared minus 3x squared. 21 minus 3 is 18. So that's 18x squared. And then x term, there's no other x term, and there are no other constants. So that's my final answer. Okay, so let's try the next problem. 3x multiplied by 3x plus 2 all squared. You have two options. You can multiply 3x to one of the 3x plus 2 first, or you can multiply 3x plus 2 squared first. So let's do the squared first. So I am going to leave the 3x as it is, but this is just going to be 3x plus 2 times 3x plus 2. Then 3x plus 2, so I am going to leave this as it is. Okay, so remember this is two different problems, so don't get that confused. 3x plus 2, so I am going to use my giant rectangular parenthesis. 3x is my first term, and then to them I'm multiplying the second polynomial. And then to that I am adding the second term of the first polynomial multiplied by second polynomial. And then close that square parenthesis. So that's 3x multiplied by 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. And 2 times 2 is 4. Again, I should be trying to simplify inside the parentheses whenever possible. So that's still the 3x is still there. 9x squared, I don't have any other x squared term. 6x plus 6x is 12x plus 4. Now I am ready to multiply the 3x. Okay, so the 3x multiplied by 9x squared. 3 times 9 is 27. X times x squared is x to the power of 3. 3 times 12 is 36. X times x is x squared. And then finally 3 times 4 is 12 times x. So this is my final answer. So I hope you're a bit more comfortable with multiplying polynomials now. Now let's get to the next thing that we're covering, which is called factoring. Okay, so when we're talking about factors in math, what are factors in math? Factors in math are numbers or expressions that we can multiply together to get another number expression. So for example, if you have 2 times 3 is equal to 6, we know that 2 times 3 is equal to 6. So we can say 2 and 3 are factors of 6 because 2 multiplied by 3 is 6. And numbers can have many factors. So for example, if you're looking for factors of 12, 12 can be multiplied by 1 times 12. So therefore we can say 1 and 12 are factors of 12. Or we can say 12 can be multiplied by 2 times 6. So 2 and 6 are factors of 12. And also you can say since 3 times 4 is 12, 3 and 4 are factors of 12. So in this case, the factors of 12 are 1, 2, 3, 4, and 6, and 12. They are all factors of 12. And since the negative numbers make a positive, because multiplying negatives makes a positive, you can also have -1, -2, 3, -3, and -4, and -6, and -12 are also factors of 12. However, we are dealing more closely with prime factors. So what are prime factors to begin? What are prime numbers? Prime number is a positive whole number that is only divisible by 1 and itself. So what are the prime factors of 12? Well, we said that 12 divides into 1 times 12 or 2 times 6 or 3 times 4. But if we actually go further for each of the numbers where like 12 is divisible by 2 and 6 again, and then 6 is divisible by 2 and 3. And if I do that for each of the division, 6 can be divided into 2 and 3, and 4 can be divided into 2 and 2. If I do a factor tree for 12, it doesn't matter how I divided it, how I began dividing, it all comes to 2 times 2 times 3. So 2 times 2 times 3 is 12. So 2 and 3 are the prime factors. So the prime numbers, 2, 3, 2 to 3, they are my prime numbers. By the way, 1 is not a prime number, okay? 2, 2, 3, 2 and 3 are my prime numbers that are factors to 12. So 2 and 3 are prime factors of 12 since 12 is 2 times 2 times 3. And so finding factors of polynomial, the essential questions you should be asking is how can I write a polynomial as its factors? So if you have 2x to the power of 4 plus 4x squared plus 4x squared y plus 4x, what multiplied by what is what I'm looking for? What is the what that I'm looking for? Or 2x squared plus x minus 15. What are the two expressions that multiplies to get 2x squared plus x minus 15. So you should be asking, how do I find the factors? And are there any factors? Can I factor any further? And what do the factors tell me? So we are going to tackle greatest common factor in polynomial. And we are going to continue in our next lesson recording.